Hi, this is Arette and Direct Incorporated. Our business revolves around all coins that have an arete finish, including specialty coins, tokens, medallions, and the Canadian dollar. Arete is denoting, made of, or having the color of gold. An electroplated coating of copper and tin completely encases the core and provides a golden appearance. Today, our presentation will uncover the important history and manufacturing process of the Canadian loonie. The reason for this production is so that a thorough understanding of what we use every day is provided. Canada's $1 11-side circulation coin was introduced by the Royal Canadian Mint on May 8, 1987 as a cost-saving measure to replace the old dollar bill. Instantly dubbed the loonie after the lone loon that's found on the coin's reverse, its nickname has been used ever since. The loon design was created by wildlife artist Robert Ralph Carmichael. More than 1 billion of these coins, which were composed of arete bronze plated over a nickel core, were manufactured between 1987 and 2012. When the first specialty Canadian dollar was created from 1935 to 1967, it was composed of 80% silver and 20% copper. The weight of the dollar then was 23.3 grams, diameter was 36.06 millimeters, and the thickness was 2.84 millimeters. After 1967, another version of the dollar was produced between 1988 to 2002, which not only decreased in weight and size, but also was manufactured out of 91.5% nickel and 8.5% bronze plating. Currently, since 2012, the loonie was made of multi-ply brass-plated steel weighed at 6.27 grams with a diameter of 26.5 millimeters and a thickness of 1.95 millimeters. A single laser mark of a maple leaf positioned over a circle on the coin's reverse is produced on each coin along with the year's specialty image. For example, Terry Fox was on the loonie, and so was Inukshuk during the 2010 Olympics. Multi-ply coins are manufactured using a unique process that delivers the most durable and consistent plated products on the market. One of the key innovations of the multi-ply process is its reliance on 2 separate heating stages. The first annealing process is used to soften the core of the coin. The second stage, meanwhile, helps reveal and relieve the mechanical stress in the plating layers while retaining the crystalline hardness of the outer nickel layer. This combination of pre-anneal and post-anneal processes delivers unrivaled durability. Typically, a finished multi-ply product has an outer layer that is about 1.5 times harder than a monoply coin. MPPS technology allowed the mint to control the plating thickness of the alternating layers of a brass and copper, providing greater flexibility in the development of the electromagnetic signatures compared to those generated by non-plated alloy coins of the same dimensions. Multi-ply coins provide 3 layers of metal coating steel core, double anneal, superior quality and durability, shorter plating time, less expensive, and high security, unlike a monoply coin or paper dollar would offer.
This right here is a blanking press. It punches out all of the coins, which will transform into the loonies that are circulated today. Excess metal is left over after the punching process. This will be melted down to be made into more blanks. All the coins are put on a conveyor belt to head over to the post-annealing oven. At this stage, the metal is extremely brittle, so it has to go through a post-annealing oven at 800 to 90 degrees to 900 degrees Celsius. This process makes the coins malleable and cleans them off. After this, the coins are then plated. Unfortunately, the heat oxidizes the surface again. A bath with abrasive ball bearings in a cauldron that is filled with a solution of sulfuric acid, which deoxidizes the coins, is produced. After about 20 minutes with acid and silver balls, the shine is again restored. The coins and the ball bearings are dumped, and those balls are then collected again and separated from the coins so they can be reused again. The acid is then washed off and the shiny blanks dance their way into the drying chamber. After this, the final step, called the post-annealing process at 450 degrees to 550 degrees, is carried out to remove plating stress, which allows the Canadian loonies to be stamped correctly. This leads to the final product of what is produced and used today.